Hey guys! Welcome back sa ating intro to data structures and algorithms. So this is part 3 and for today, we will be talking about what is algorithms right after this intro. Okay guys, so let's talk about algorithm. So ano nga ba yung algorithm na sinasabi natin? So ang algorithm is just a set of instruction designed to perform a specific task. For example, in programming, pwede siya maging performing math operations or even complicated operations. For example, gumamit tayo ng for loop and then manipulate natin yung data dun sa loob nun. So it's already called an algorithm. So anything that you do to a data, you're using an algorithm. So it's just a step-by-step procedure. So ang algorithm daw are different from actual implementation. So, nakita na ba kayo ng algorithm? So, algorithm kasi yung pinaka-logic pa lang. Hindi pa naman yung pinaka-actual code. Kunwari sa C++ or sa Java. So, hindi pa naman yun yung pinaka-actual code. So, tinitingnan pa lang natin yung parang prototype ng itsura nung magiging logic ng system natin. Okay? So, ayan. So, believe it or not, ang algorithm is just a fancy word of saying na this is the step-by-step procedure. So, ganun lang kadali yun. So, now let's look at the algorithm characteristics. So, number 1, we have the input. So, you should have 0 or more inputs. So, minsan kasi hindi naman kailangan mag-input ni user. Meron na kasi input na naka-predefined. So, okay lang kahit minsan walang input. Pero kadalasan yan, merong input yan from the user so that we can perform yung algorithm dun sa data na in-input ni user. Then, second, we have the output. Of course, 1 or more output. So, pag walang output yung algorithm, no, di ibig sabihin, walang kwenta yung algorithm. Kasi nga, kaya nga tayo gumagawa ng computation sa mga algorithm na yan to get something out of it. Okay? So, thirdly, we have the unambiguity. So, meaning, clear and simple dapat yung algorithm natin. So, kung may paulit-ulit dyan and kung merong parang walang kwenta na part dyan, then it should be removed. So, yun yung sinasabi natin na merong ambiguity. Okay? So, ngayon, meron tayong finiteness, which is, eto naman, limited lang yung instruction natin. So, meaning, hindi siya forever nagra-run. So, yung algorithm, meron lang yan limited steps. Okay? So, pagka hindi natatapos yan, then there's something wrong with your algorithm. For example, yung for loop natin or yung loop natin, nag-ulit-ulit lang forever. So, that's not an algorithm. There's something wrong with that. Okay? Then, lastly, we have the effectiveness. Syempre, yung impact ng every step. So, kung meron kayong step dun sa algorithm nyo na wala namang ginagawa dun sa data, then probably, you should remove that. Dahil wala siyang binibigay na impact dun sa data na binigay natin. So, ibig sabihin, walang kwenta. Sumasayang lang siya ng resources. Okay? So, yun yung mga characteristic ng algorithm natin. Ngayon, let's talk about the flow of algorithm. So, of course, meron tayong input. So, yung mga kailangan natin value to perform our algorithm. Then, we have the process, yung mga operations na gagawin natin dun sa input natin. And then, finally, our output, which is yung result natin from our algorithm. So, ngayon, let's look at real-world algorithm. So, ito ang algorithm of cooking pancit canton. So, biruin nyo yun, meron palang algorithm ko paano mag-cook ng pancit canton. So, sabi ko nga sa inyo, ang algorithm is just a set of instructions. So, parang procedure lang siya, no? Parang binigyan lang kayo ng recipe. And then, ganito lutuin yan, ganito gawin yan. So, number 1, boil water. So, yan yung input natin, di ba? Yung water, isa yan sa mga input. Then, put noodles in the boiling water. So, of course, yung noodles din, input yan. Then, prepare the sauce in a plate. So, yung sauce, input din yan. And yung plate, lalagyan yan. So, parang ginagawa na natin yung process. Diba? Binoil natin yung water. It's a process. Nilagay natin yung noodles do sa boiling water. It's a process. Ginagamit natin yung mga input natin to process those things. And then, nag-prepare na tayo ng sauce dun sa plate. Then, next, we will drain the boiling water. Another process. Then, number 5, put the noodles in the sauce. So, another process. And then, stir until the noodles is covered with the sauce. So, yan. Another process ulit yan. Then, serve the pancit canton. So, meaning, ayan yung output natin, yung luto na pancit canton. So, as you can see, meron tayong input, then we processed it, and then we finally have our output. So, that's what algorithm is. Okay? So, sobrang dali lang naman intindihin, guys. So, yun. So, ito naman ang itsura ng programming algorithm. So, sabi dito, create an algorithm that adds 2 numbers. So, as we can see here, it doesn't really use specific programming language. Gumagamit lang siya ng English words. So, may intindihan pa rin natin siya kahit hindi kayo nagpo-program or hindi pa kayo sanay mag-code. Makikita nyo dito, mag-declare muna daw tayo ng num1, num2, and sum. So, we can create an algorithm that adds 2 numbers. Okay? So, kailangan natin ng num1, num2, and sum. The next, we need to input yung num1 and num2 kasi yung dalawa na yun yung pag-a-addin natin. Then, of course, i-read na natin yung num1 and num2 kasi yun yung pag-a-addin nga natin. And then, we will process it. Yung sum daw natin is equals dun sa num1 plus num2. So, meaning pinag-add na natin sila and then nakastore na siya sa sum. And then lastly, i-output lang natin yung sum natin. And then, there you have it. We have our input, we have our process, and then we have our output. So that's algorithm. So I hope na naintindihan nyo. And then algorithm versus implementation, eto na yung pinaka-implementation niya. So if you create a program that adds two numbers, so this uses C++, may kita nyo, meron tayong int main dito, eto yung main method natin. Then we have our declaration, so nag-declare tayo ng num1, num2, and sum. Pina-input natin yung num1 tsaka num2, so makikita nyo itong cin yon. And then, ito yung process natin ng sum is equals to num1 plus num2. So, pinrocess na natin. Kinuha na natin yung sum. Then, finally, we outputted yung ating sum. So, yan. Cout, sum, and then yung sum natin na nakuha dun sa algorithm natin. So, yun. So, ito na yung implementation. So, there are different implementations niyan. So, if you use Java, iba itsura. If you use Python, and kung ano mang programming language yan. So, yun ang algorithms. So, ngayon, ano kinalaman ng algorithms sa data structure? So, bakit natin pinag-aaralan to? Kasi guys, ang data structures are set of algorithms that organizes data in a certain way. What do I mean? So, yung kada data structure natin guys, meron dyan nag-govern na algorithm. For example, gumawa tayo ng data structure na nakasort alphabetically. Every time na may nadadagdag dun sa mga data natin, yung isang data na nadagdag na yon, gagamit yun ng algorithm to know kung saan siya ilalagay. Kunwari, letter Z. So, letter Z yung pinasok natin na bagong word, zebra. So, syempre, may iraran na algorithm yun to figure out kung saan natin i-store yung zebra. Since yung zebra should be on the letter Z kung naka-alphabetize tayo. So, ganun yung algorithms and data structure. They work together. Okay? So, para ma-organize yung data natin. Yun. So, ngayon, there's one more thing that we need to consider, and yun yung algorithm complexity. So, what is algorithm complexity? So, it's an algorithm's performance. So, paano siya na may measure o kung gaano siya kumain ng oras tsaka ng space. So, that's what we call the time complexity. So, yung time complexity, it represents kung gaano karaming oras ang kailangan ng algorithm natin para matapos. Then, next, we have the space complexity from the word itself. Gaanong kalaking memory yung kailangan natin para ma-process natin yung algorithm natin. So, sobrang rami ba yan? So, kadalasan kasi sa AI, yan ang malaki yung kinakain, yung space saka yung time. Pagka gumamit tayo ng AI, di ba, meron na tayong mga stable diffusion, yung mga nagge-generate ng images. So, yun. Malaki yung space complexity and time complexity ng mga yun. That's why it's very important for AI na i-utilize tong pagko-compute kung gaano katagal sila mag-process ng mga data. So, syempre, pati sa mga simple na program, there's always a time complexity and space complexity. Pero kadalasan, puro seconds lang yan. So, 0.5 seconds, ganon. So, hindi naman sobrang lala. Okay, so, under the space complexity, marami pa tayong i-consider. Marami pang factors yan. So, number one is the instruction space. Yung instruction space, guys, is yung size ng executable file natin that varies depende kung gaano karami yung lines of code natin. So, meaning, yung pinaka-instruction natin, di ba yung code natin, yun yung instruction natin. So, kung gaano karaming space yung kinakain nun, yun yung instruction space. Then, we have the data space. So, kung gaano namang kalaking size yung kinakain ng variables natin and yung constant natin. So, kumakain niya ng RAM, di ba? So, I explained it earlier, yung random access memory dun sa last episode natin. Then, we have the environment space. So, ito medyo mahirap to explain. What this does is, yung size naman i-require para i-store yung environment information to resume a function. So, kung alam niyo recursive function, pagka tinawag niyo yung isang function, sa loob pa ng function, of course, it will store yung pinaka-parent niya na function. And then, medyo mahirap siya intindihin, pero once we get there, you will know. Parang nag-i-stack yung mga function on top of each other. And syempre, i-store muna natin yon in a temporary storage. And that's the environment space. Okay? So, yun yung space complexity. So, with that being said, yun lang ang algorithms natin. So, I hope na namin kayo natutunan. If you have any questions, just comment sa ating comment section. Kung wala naman, then, yon. Thank you for watching this video. As always, guys, I will see you in the next video. Goodbye!